listened in geotechnical engineering at IGC Kochi 2022 and outstanding civil engineer award by ACCE Alternate at Hyderabad in 2023. He was awarded the Lifetime Achievement Award by the Deep Foundation Institute in 2024. Professor Madhav delivered the convocation address as chief guest and orator at JNTU Anantapur in 2025. Most recently, he was awarded the first Asian Lifetime Achievement Award in 2025 by the Asian Society of International Society of Soil Mechanics and Geotechnical Engineering, and outstanding contributions medal in December 2025 by the International Society for Computer Modeling and Advances in Geotechnical Investigations and Mechanics. Over to Dr. M.R. Madhav.
Yeah. Thank you, Anshuliji. Now I request our Dr. M.R. Madhav, FYE, to give his presentation. Thank you.
I just want to add one point. Professor M.R. Madhav was 1 year junior to Engineer Krishnamurthy garu, it seems. Today only I came to know. So they studied in the same Andhra University College of Engineering. Okay.
Once Surya Prakash had just had started the slide, I'd like to thank Surya Prakash and the Institute of Engineering for giving me this opportunity. In the awards that they did listed, one of the most prestigious ones which I cherish is the Vishweshwara Award given to the Institute of Engineering way back in 2007. I just would like to say it has been an honor. I think you can hear me clearly.
Yes.
Okay. Professor Raju and me were parallel workers from last 70 years. We joined engineering in 1956. We graduated in 60 and we have been having parallel careers. But what I'm going to present today would be a very different perspective based on my experience working in India and all over the world. I had great opportunity to work, and I feel there is something we can do together to make the practice of geotechnical engineering rational, economic, functional, and appropriate for the country. There are lots of gaps in our practice, which I want to highlight. Even the perspective I'm going to give will be very, very different. Is it okay, any problem?
No.
Okay. So basically, what I'm presenting today would be what you can call GeoSutras for structural engineers. The subject of soil mechanics is exactly 100 years. In 1925-26, the first concept came by Tazagi in Vienna, and we are celebrating the 100th year of soil mechanics, or we call it geotechnical engineering. On this occasion, the International Society has been preparing what you can call as a time capsule of all the major contributions of people who contributed to the profession. So they had requested me from India. So I wrote a set of GeoSutras based on my experience, which have been now accepted by the International Society, and they will be releasing there too. Based on that, our Indian Geotechnical Society has published the volume here. It's called GeoSutras from Basics to Ground Reality, which is a very different perspective. So when Surya Prakash asked me, maybe there is something like that I can prepare for the structural engineers. I've been interacting, but there's a big gap between our thinking and that of the structural engineers. And this is what I want to bring out today. And I hope we'll be able to communicate better, bridge the gap so that the profession benefits in the wellness or improvement of quality, service, etc. So what I would like to present from now would be, basically the problem with geotechnical engineering is like this elephant. People look at it and they say different things. Somebody says soil is this, somebody says something else. So we never agree on any of these things. Probably the complexity is so high, we probably will not be able to get a complete picture. unless you are mature enough to understand the whole. So this is just to highlight. So basically what I would like to say is that these are the GeoSutras I presented to the International Society, that the ground and soil are not the same. Soil is an element I can pick up in my hand. Ground is an entity at the site. So there's a big difference between those two. Okay, ground is not homogeneous or semi-infinite, which is what many of the people in the analysis assume. Ground in nature, in most of the time, is over-consolidated. That is, it has been subjected to higher stress, and that is why, if we don't consider that, we over-predict sediments, and Balaji highlighted that actual sediments were much less than anticipated for the simple reason the over-consolidation effect is ignored. The other one which I will be presenting also, ground is not steel. Coming to bearing capacity, the whole concept came assuming the ground to be steel. And I'll show you why. And the properties that you get from these agencies are from the laboratory. The ground has a very different set of parameters. And I'll elaborate on these in my presentations too. And then, of course, there are many other things too. But what I would like to come back to would be, what are the GeoSutras for the structural engineers? Again, soil and ground are not manufactured material. The problem with structural engineers is they deal with cement, steel, concrete. They don't deal with the natural material. I'll come back to that again. I think Balaji said, and we've been talking with many people, investigations are done before the structural design. It should not be. It should be part of the whole project. Somebody gives a report and they think we should not even accept the recommendation. I think we made a point that you only take the factual report and never take the recommendation. Most of the agencies are not qualified to give any recommendation. And I'll illustrate why it is so bad. Then people think bearing capacity is a unique value. Honestly, it is not. It is a structure, broad interaction parameter. So many other factors which I want to highlight. The other important thing I feel very sad is in India, people believe in code. They say we need a code. For a design, code should not be there for a complex material like soil or ground. Instead, Eurocode only gives you the guidelines of parameters to be taken. It doesn't tell you. Same thing in Japan. But in India, everybody wants, because the structural design, you need a code, maybe. And we think code is needed. I don't believe the code should be used. The designer should have the ability to take the challenge and come out with the solution. This is the sad part of it. Then plate load test, everybody asks. It's one of the waste material waste tests. You cannot interpret extrapolate it. I think Balaji also said, we think piles are like broad spectrum antibiotics. Any problem, go for pile. Honestly, we don't need pipe most of the time. And I've been able to convince several projects in my own experience that we can save a lot of money. Actually, I'm going to give another presentation that it's good for the sustainability and reducing carbon footprint. Okay. The other thing is every site in Hyderabad, before doing anything, they start excavating. Then they come with a problem. On average, I go to about 3 to 4 sites with a crisis. It's slow fade, God forbid 1 or 2 mortalities are there. Once got a call at 8:30 in the night, said, please come to the site, it's an emergency. My wife was telling me, I can understand a doctor having a problem. Why you had to go? But I had to tell her that the way the practice is, people, they think digging, the contractor is very happy, you can see some action on the site. And then they dug up and first entry rain and collapsed. Something happened and the next building is in trouble. And so they had to get some firefighting to be done. So don't do it, okay? The other thing is people treat geotechnical engineers as service engineers. They don't treat equally. I'm coming back to that in the end, which I'm going to show that Bombay Municipal Corporation made it mandatory. For every project, you have to have a geotechnical consultant separately. Just like, you can get any building sanction if a structural engineer or an architect signs. Do you need a certificate? Don't we need a certificate when you go down and excavate 4 basement, 3 basement? Unfortunately, no, not in that. I've been trying to, I wrote maybe half a dozen letters to GHMC, but nothing happened there. The biggest challenge is the agencies which are conducting investigations, which all of us know, they come under L1 category. They are not qualified. They can only give whatever probably investigation they say, even the lab test. I think Professor Jagdish may differ with me, but most of the tests are not qualified or reliable. Okay, last one, of course, I said, don't insist on IS code. If anybody comes and says, design according to IS code, I say, thank you, no, because I can give you a better performance, more economic thing, more rational design than that. I just want to give you an idea. Look at the kind of soils we have. I put on the right-hand top corner. The variety of soils are infinite. You can have gravel, soil, sand, silt, clay, brown, black, whatever it is. And if you look at the bottom right-hand corner, we see the people. If you look at country, do you think all people in this country are the same? We're all human beings, I'm not saying, but can I say that, can you see the variety from Northeast Arunachal Pradesh north to Kerala or Kashmir to Kanyakumari? And look at the ground, the left-hand top corner. If I have an X-ray, I can visualize this is the kind of strata. You have different layers, different thicknesses varying everywhere. Or even a simple bridge site. Can you see how the thickness varies? At the center of the stream, you have a high, soft soil. As you go toward the embankment, the apartments or the bank, you have a different strata. Can I give a single value for this site? That's the biggest problem, the challenge we have. I want to again show a very interesting thing. We have a class hall here, we are about probably 7,500 people. Right? I want to predict the behavior of the group here, all the 100 people. Can I talk 1 or 2 people, do your, whatever pathological tests and predict? There's a big difference, and I want to say there are 2 things in this world which are natural. One is ground, second is the human being. We are not manufactured. So you think you can define a human being easily? That's the point. If you have an individual, I can talk to him. If you have 2 people, small group, then we can easily, or if the husband and wife, they have a problem. Then if you have a large group, maybe 100,000, etc., we can, that's how the politicians, sociologists work on that. Then we have a huge crowd, 10,000, 20,000, right? Can I say the behavior of the individual is the same as that of a crowd? The point is, even the crowd start becoming a mob. You know what's the difference between a crowd and a mob? In a crowd, you have your individuality. In a mob, you don't have. Somebody says, burn that bus, kill that guy. Does anybody think? No. Similarly, I have a small soil element which I test in the laboratory, or I have a ground. When I go to a site, maybe it is something like 100 meters by 75 meters. That's a large area. Can I take 2 samples which are 75 millimeter long, 37.5 millimeter diameter, and get some property, and they say this is the property of the whole ground? That is how it is. Same problem. Again, just like crowd in mob, we don't have in Hyderabad, but I think he mentioned about Delhi capital region or this. The ground under an earthquake becomes a liquid. We call the phenomenon liquefaction. What happens? The soil loses its strength. The ground loses its strength. We thought it is a solid. It becomes a liquid. That's a problem. I just want to give you 2 examples. I know that you can see. These are all routine things I get. Somebody goes to a site. This is in Old City. They have gone to 4.5 meter excavation. They did borehole. They got refuse a bit. They could drag SPT. N value was more than 100. Can you see the very capacity they recommended? 10, 20, 30 tons. This is what they have done. And pardon my saying, 90% of the structural increase want to take that as a holy number. Once the report is there.
Tell recent example, sir.
Yeah.
What is recent example of the?
Yeah, I mean, I can tell you any number. We have done, I think, those who came to me, I have been able to help them. And some of my colleagues, including Rajkumar, everybody will support them. Another side, this happened again 2 weeks ago. Look at the kind of materials. You can see like there's a rock. And again, at the site they recommended 25 tons per meter square. Whereas you could have gone 75 to 100. Imagine the amount of money you save, the amount of time you save, the amount of concrete you save, and what will be the benefit. This is on the positive side too. So there are some other problems too, but I'll come to the third one. This is a multi-story complex in one place where they had, it's an alluvial soil as you can see, and values increase with them. And the report says go for pile foundation. They recommended very low bearing capacity, but pile capacity of something like 120 tons. They came with the same data for me. I said, this is ridiculous. This ground can give me a very high bearing capacity. After my calculation, I gave them a value of something like 300, I mean, they gave more, but they decided on 223 tons as the pile capacity. They are not very sure. I'm sorry, 316, sorry, 24 meters. I gave 320 or 316 tons as the pile capacity. This is it again, Ghaziabad and Noida. And I said, I can prove it. So when they did the test, this is the load displacement graph. And you can see when you go to 550, 570 tons, the settlement is hardly 7 millimeters. I said, if you're ready, you can go up to 450. But of course, no, they saved anyway about 40% of piling, which means cost became much less, and they were very happy with that. Okay. So what I want to present to you would be very important. The important thing in science of life is not so much to obtain new facts as to discover new ways of thinking about it. Please remember, I want you to switch off from your traditional value, thinking that soil ground is something I can test and get the value. It's much more than that. And I want to tell this to structural engineers that they're very good at designing something above the ground. But every building has to rest on the ground. Isn't there an intermediary which takes the load from the structure, transfers to the ground? It is called the foundation. So don't you think the people who are investing so much on structural design, they should know how the ground behaves or at least interact with people and come with the proper design. That is the biggest problem. And the reason is, I can tell you, there's a lot of difference between structural and geotechnical engineers. They deal with steel, whether you buy from Tata, ArcelorMittal, SAIL, the properties are the same. 415 megapascal, 210 gigapascal, 550, whatever it is, okay? And concrete, you say I want M35, M40, they're again manufactured material. And most of the time we get from RMC. And you know the property. But as a geotechnical engineer, am I dealing with the manufactured material? It's a natural material made of, if you are spiritual, you say God, and the properties are constant or variable. You add water, what happens to the soil? It becomes soft. If you dry it, it looks hard. So can you say it has a property? No, that's a problem. So there are a lot of complexities when you are looking at the interaction. Please remember the three things: the ground, foundation, and the structure. It's not one alone. You have to have that perspective. There's a lot of uncertainty in ground conditions. If you put two boreholes, one here, another there, will you get the same characteristic? No. How much do you spend on geotech exploration? Normally, we recommend half to 1% of the cost of the project. People are thinking about it. They say 10,000, 20,000. And as is, some other people I know, they're like bargaining when you go to buy vegetables or something. They say some kilo is 40 rupees. Can you give for 30 rupees? They said exactly the behavior of some of the client. Can you do with less number of boreholes? Can you cut down the number of the depth of the borehole, etc.? This is how they do that. The behavior of the soil is as complex as human being. The interface, foundation, soil, pile, soil, they're all very complicated. And how does it respond? And a lot of other problems. How do we construct? The other last thing would be structural engineers use a lot of mechanics. Very good theory of velocity. It works. Geometry is known. You have a column, beam, slab, etc. Are there any complex geometries? Unless you're looking at one of those very special shells. Material properties are known. A lot of theoretical solutions are available. And you have a code for the design. I'm a geotechnical engineer. I'm looking at a variable geometry. I showed you how the varied properties of strata vary at big depth and over the site. Highly variable. I cannot even know the property or design precisely. I can't determine it. And you give me any property, I show you the opposite is also true. Okay, loading is very complex. So when I give a decision, it is not code-based, it is judgment-based. I use judgment. That's what I do. So here I want to say something. Those of you who are married, I would recommend you read this book. Men are from Mars, women are from Venus. It's a fantastic book by John Gray. You will understand your spouse. If you are a male, you are a left brain oriented, highly logical, analytical. Women are right brain oriented. They have much more better vision. They have image processing. They have fantastic languages and other things. I'll give a simple example. I want any of you to try. Please, if you wear a wristwatch, cover it. Can anybody try? Can you cover your wristwatch? Can you tell me what is the dial? Is it a Roman numeral, Arabic numeral? No. Without I can tell you 90% of the men would know. But you ask a lady, she goes to a party, she remembers who wore which saree, which jewelry, and she will remember whether they wore it in the previous function. This is a fantastic right brain oriented creativity. What you need when you're dealing with ground is that kind of right brain oriented work. So structurally these are from Mars, geotechnical, they are from here.
So we should encourage more women in geotechnical.
But no, it's not, men are there, but they have to use their right brain. You can't take away the men. They're already there, but it's going to be in geotechnical engineering, in tunnel engineering, we have a lot of women. They're coming and we're okay. Basically, now I come to the bread and butter, the carrying capacity of foundation. All I would like to say is that people think it is functional strength with C and Y, but we realize ground is very different from a strong widget. It depends on the geometry of foundation. Bearing capacity has nothing to do with soil alone. We have a simple equation, C and C, Q and Q gamma, and half gamma B and gamma. It depends on the width of the foundation and the depth of the foundation. How do you say it's a property of the soil? Tell me, a structural engineer with all his knowledge believes that it's a single value. Okay? But sometimes you don't even need strength. It can be stiffness alone, as I'll show you later. Here is the biggest joke of the lot. Can you see the left-hand corner? I've put all the civil engineering material. Stress strain curve for steel, the low yield stress curve, the concrete, M50, M15. And if I plot my soil property or ground property, the stress strain curve is along the x-axis. But all our design is based on steel. Do you think it's possible that you can simulate or assume soil is anywhere near a steel? Large deformation, highly compressible material. Just to give you an idea, these are the numbers. Steel, ultimate stress is 415 MPa. The E value is probably 2 into 210 gigapascal. Whereas if I look at soil, The strength is hardly 50 to 100 kPa. The modulus may be 1 MPa. And we assume the bearing capacity theory given by Terzaghi way back in 1940 is valid even now. This he gave because Terzaghi was a mechanical engineer and he studied Prandtl mechanism. Prandtl worked on punching of metals. You got an ingot, how do you press it with this thing and get a sheet or a beam or roller? And he took the theory, and this is what we all accept now. In all textbooks, it is there. It's terrible. I'm trying to convince that we should not teach this at all. Then we said, oh, no, it's compressible. So we said general shear failure, local shear failure, punching shear failure. Then we come with some. But honestly, it's not that simple categorization. Any of us today, I'm very happy. Tomorrow I may be sad, in between something else. We keep changing. It's a gradual transition. There's nothing we can say specific. We should come with appropriate theory, which we have been doing it. It's available instantly, but we don't practice it. Then this is the simple load segment graph for a foundation. You can see that as you increase the load, the segment increases at some stage, it becomes so large, it may tend to fail. We take the ultimate value, divide it by factor safety, I get the safe one. But still, we have to satisfy another serviceability criteria, which means how much segment do I want. So I come back to the segment criteria. And here the unfortunate part is don't divide the ultimate with the factor safety. You divide only the additional one which led by ultimate bearing capacity. You get something more. But these are all based on assuming the soil to be homogeneous. That means the properties are the same everywhere. But it doesn't happen. These are the typical examples of how the strength varies with depth. At some point, it's very high, it decreases linearly. I can give you any number of such things. So we normally try to simplify them in different categories, and we can come out with the bearing capacity as sophisticated as you want based on the ground conditions. As you can see, if I consider the increase in strength with that, which is what most of the time site, if you go deeper, you get a higher strength. You get about 30 to 50, 100% more bearing capacity. We don't accept it. We have several situations where I can give you the solution for homogeneous, finite layer. You get hard rock. In Hyderabad, for example, we are very lucky. You get very good soil within, very good hard rock within 10 meters or 8 meters. So we can come with this. Now, let me come to another. People want a plate load test. I don't know why, because they think some load tests I have confidence the ground can take. Just imagine, a plate is hardly 300 to 450 mm in size. The zone of influence is twice that, 600 to 900. Whereas my foundation is 4 meters. The influence is 8 meters. Can I extrapolate from 600 mm to 8 meters? The ground conditions are very different. That's the problem. So if somebody comes to me, I said, don't waste your money on plate load test. Then the other thing, as just somebody recently said, we are going, as number of stories are going up, 30, 40, 50 Hyderabad, I think I'm going to 60. You want to make money, so you want to go down. 3, 4, 5 basements are common. Once you go below, you have a bonus. How many of you realize this concept is called floating foundation? If I remove, say, 4 basement, 3.5 into 4 is 14, plus 2, 16 meters if I go, I have removed 16 meters of soil. So, which means the soil has been unloaded 16 into 1.8 tons per meter cube, say something like 30 tons per meter square. Even if you put on the ground will not know. This is a problem in all these investigation agencies. They give you bearing capacity of 20 tons at 5 meters. I removed all the material, soil doesn't feel anything. So we are missing a lot by not considering how much excavation, how much material we have removed, which is a bonus. I want you to tell all the structures, please remember. I mean, I may charge a little bit, but I can give you my worth is Many times I give them an option. I give them an option. My consulting fee is some X amount, or you give me 10% of money you save. Then they agree what I said was okay. This is the problem. They think whatever I give is still too high a figure. So basically, by going deeper, you are gaining a lot in terms of carrying capacity. Please remember that. Then going deeper is other problem, excavations. And this is the biggest problem I find. Everybody wants to dig first, even before they design the whole thing, and it collapses. It is very easy if you spend maybe 2 to 5 lakhs to do the nailing and support. There are many ways of supporting it, but we recommend normally nailing. And I find I can tell you any number of horror stories. Even in Hyderabad, my recommendation would have been about 2 to 3 lakhs spending. They said, why should I waste my money? Then the excavation collapsed. The neighboring buildings were affected. It became a police case. All the people from the building had to be put in a hotel and lodge for 3 weeks. They spent 50 lakhs. In one case, there was a mortality. And you know what happened? The police come, the politician come. The guy spent 1 crore. All because he wanted to save 5 lakhs of freedom. This is the kind of penny-wise pound foolish. Or we say stitching time. The other thing is this very capacity is a very crazy thing. Honestly, I give the whole thing is based on foundation. They never looked at the structure. But now structures are going higher and higher up. Okay, if you look at it, the higher the structure, bearing capacity is not the problem. It has the tendency to tip. I wish I could show a simple example. Or you go home, you put, if you have some heavy books, put them on a table, and they will all stand one over there. You put a pillow, and on the pillow you put the books, and show me whether the books will be stacked straight. This is what happens if I put a tall structure. So some simple, simulation we did in the computer. I took a 60-meter tall structure and put in a 20-meter diameter foundation, and then we took some property. Look at this. Depending on the compressibility of soil, if the G by SG is the shear modulus, SU is the understand. If I have a low compressible, highly compressible one, it rotates and fades much below. And if I increase the shear modulus or reduce the settlement, I get a higher capacity and less rotation. So this phenomenon, we call it as a leading instability, and structural is no buckling. I keep saying that this ought to be considered too when you are looking at tall structures. They have a tendency. We can easily prove that it's sometimes a function of time. Over a period of time, sediments increase. So we may have this leading instability. Tower piece as a classic example. I have at least half a dozen cases in India where the towers are leaning. We don't accept it, but that's a different story. So I just demonstrate now in my lab, etc. If I reduce the height, put a small foundation, or if I put a low-rise building or a high-rise building, I get different load capacities. If the height of the structure is less, I get higher bearing capacity. Height of the structure is more, I get larger value. And this is the book's example that could be. So I just applied this mechanism, and it's very easy as a leading instability, structural engineering, give you the Euler formula, etc. We have a very simple one. The critical height into sediment by radius of gyration. If it is 1, it's going to collapse or tilt. And you'll be surprised. The tower P size is exactly 0.96. So it is actually leading instability, it is growing. So I come back to our story that we do investigation. We put a auger, take some soil, which we call remolded soil, and then other one. It's supposed to be undisturbed sample. But there's nothing like undisturbed, a very crude way of doing it. And then based on that, we get liquid limit, plastic limit, and then classify soils, clay, silt, highly plastic, low plastic, etc. Then grain size varies and permeability can change a lot. sands are 10 to the power of minus 3 centimeters per second, clays are 10 to the power of minus 8 centimeters per second. So whole range. The other thing I want to show you, everybody is worried about expansive soil, black water soil. Honestly, they're not a problem. We're all afraid of COVID. But if I put a mask, did I protect myself? So if you can think of black water soil is not a problem. When you add water, it's a problem. So if I don't allow it to come to water, there's a problem. I have a simple solution here. How the water content changes, the linear increase is the neutral one. In rainy season, the water content increases to the top, and in summer, the red line shows it decreases. But if I go 2 meters, 2.5 meters, there's no change. So all my recommendations are for structural engineers. Just don't, it's because of black on soil, don't panic. You go to 2 meters and put your footing. You get very capacity of 50, 70, 80 tons. Even compound walls are built. Just go 1.5, 2 meters, put your footing at every column would be something like 5 to 7 meters. Put a great beam, put your wall. So unnecessarily we are panicking because we are not thinking about it. And then we some simple tests we do. Recently we did some project where we found that the expansivity is very low. So why worry about it? The other thing is the joke is this so-called undisturbed sample. The sample is at point A in the ground. During drilling, the point goes to B. During sampling, it goes to C. It bring it to the lab. Finally, when I test it, is at point F. We are determining the property at F, whereas the point in the ground is at A. There's absolutely no relation between what you get from the lab and what you get from the field. And these are the kind of stress strain curves. The one on the top is the real behavior of the ground. The ones are below are the what you get from lab. Very different. So I had to use my judgment based on this how to come back to the proper value. So I try to depend on different correlations if I have a natural water content. Please insist if they are going to test it, get me the natural water content, which I think this is something you should insist. The least thing is they do on the site. We have very good microwaves too. You can test it in 5 minutes and get the value, which is very reliable. Not like other properties. The other thing is the more you spend, the more accuracy you get. If you spend less, people say, I spent 20,000, 30,000, I get a report. But the foundation design, concreting, site is much more. Whereas if I spend more, if I can reduce it, it will be better. So there's always a relation, how much you spend on investigation and what accuracy you get, how much saving you get. So I tend to believe that laboratory values are not reliable. Try to go for in situ. SPT is a very common one, but I would recommend the core penetration test, which is very, very reliable. There are much more sophisticated ones, which are used in Europe, Japan, etc. But in India, we're very conservative. We don't want to spend money, so we don't. So if you do peanuts, you get monkeys only. That's the kind of thing. So you end up with all these agencies in Hyderabad who will give you some value for somebody comes to your site. I'll give you 1,200 rupees per meter. I'll give a report. Whether he put even 5 more holes on, nobody knows that. They're all manufactured too. So that's the problem. So what we do is we put SPT, we drive a tube, put a hammer, drill it, hit it, and then get a value. I want to say that we can determine quite a few in terms of even that value. If the value of n is between 0 to 4, I know it's a loose sand, relative density may be 15. If the value is 4 to 10, I know it's a mid loose sand. Then if it's 10 to 30 medium, then I get a feel for that. This is what I try to derive, combined with many other things. Okay, then I have a lot of other correlations too. Then we have the core penetration test. SPT is one number, please remember. Core penetration, I get 2, the tip resistance and the shaft resistance. You get continuous profile. SPT I get only at every 1.5 meter interval. It's a very slow process. Whereas with core penetration, I get continuous. And even if I don't see the sample, I can classify. whether it is sand, clay, silt, many more classifications. I don't want to give the whole lecture on that. We also have how to correlate one from SPT to cone penetration. I have some relations too. So I use them sometimes to convert one to the other. Then we are doing a lot of dynamic tests. Wave propagate is one of the best ones. If I as a person go to a doctor, they're doing a lot of ultrasound, CAT scan, NMR. What are they? Basically sending a signal, finding out what is inside. This is exactly what we do in geotechnical engineering. I can find out cross hole, downhole, uphole, whatever it is. I can get all the properties. Dynamic properties, which again I use now. Then we have a very sophisticated one, which is called MSW, multi-axis surface one. I give an impact somewhere and pick up the signals over a distance. I get the whole picture. Okay. I can get this. This is a very sophisticated one. We are all very good in accepting a smartphone. Is there anybody here who is not using smartphone? Is anybody traveling with Bola card? We do all that later. But when it comes to geotechnical engineering, we want later, we want Bola card or even something bad. That's the sad part of our practice. Okay. Then it comes to planning. Do we involve a geotechnical engineer in planning boreholes? The qualified guy. You had to decide what is the project, what are the locations, how many boreholes should I put, what is the depth, etc. So we had to work with a geotechnical engineer to decide on that. Okay. Here is one example of a tower foundation multi-story. Look at the number of boreholes they're putting. You are investing something like 500 to 700 crores. Don't you want your investment to be safe? Don't you think you should cut? Suppose if I give you 100 crores, will you just dump it in some bank or something, or will you make sure that your investment gets a good return? This is what I want you to think as a structural engineer. My job is to make sure we get a good response from the ground. And how do I go to putting number of boreholes? Consult a proper guy. Otherwise, you end up with a scamster. These are how the report should come. How do the properties vary with depth? Without that, I can't do anything. Okay? This is how we'll try to get as many as possible. I want to show it's not very easy. These are another site, alluvial marine site. Can you see the properties how they're varying? Can I give a single value or should I look at the whole thing? Okay. And if you look at the right one, this is the sand part of it. The top curve is the real behavior of the ground where you have a very flat deconsolidation, free loading, and the steep convergent consolidation. Everybody predicts large sediments, but they don't get, which is exactly what Balaji has told us. That is because we ignore the over-consolidation effect. And I normally try to come with this picture. How to divide the strata, unique weight, SPT, whatever properties are. Based on that, I do the analysis. These are some other variations in which I can put in. You had to visualize the ground and assign properties at different levels. It is not a simple homogeneous value. Then I had to work it out based on that. Okay, these are the kind of things. Okay, now coming to the part which code-based kind of thing. Exactly in 1967 gave something. IS code still has that. Everybody knows that is over predicting. It's very unsafe. They said you can increase. Near of 1970, they said increase by 50 to 75%. But unfortunately, in 1986 and 85, 71, we have better methods of estimating. You give me a site, and with a proper investigation, I can do a good analysis of finding out how much sediment it can predict, which is more related to the actual ground condition, not on a simple chart. Similarly, if I use core penetration, we have a Schmettmann method. I can again predict more accurately. and I get good values. Then I come to one other very important philosophy that I have, which I have been saying that piles are not the answer. That is because all our textbooks, right, saying that there's a shallow foundation and a deep foundation. Am I right? Do they talk anything in between? I said, no, there's a third alternative where I can give you a solution. So what I did was, I looked at the structures. I call them light, medium, heavy, and heavy. Light structure is 1 or 2 story small building. Maybe you get very capacity, load equal to 7 tons, 8 tons per meter square. Medium is 5 story, 7 story. You may get 15, 20, 25 tons per meter square average load. Heavy structures are all your bridges, whatever structure, very heavy structure, tall structure. So, 3 categories. Then I said the ground, I look at it soft, like a marine clay. You go to Visakhapatnam, Tuticorin, Chennai, Goa, very soft soil. 100 strength is 10 to 15, 20 kPa. Medium step are all alluvial soils in Indo-Gangetic alluvium. Most residual soils all over Deccan Plateau or medium step. That means strength could be 50, 70, 80 kPa. Then you get hard rock. Look at the matrix. If I have light structure on soft soil, I can provide shallow foundation or improve the ground. When I talk of improving ground, I increase the strength. Medium structure, ground improvement I can do, I don't need. Only when I have a heavy structure on a soft ground, I go for deep foundation between piles or well foundation water. Medium stiff soil, light structure, shallow foundation. Medium stiff soil, medium heavy structure, ground improvement is enough. Even heavy structure on medium stiff, I can do with shallow foundation and ground improvement. And if you have hard stratum, no problem with go for shallow foundation. So this I found is a very good way of handling things. So you don't have to go for deep foundation unless it's a heavy structure and you have a soft ground. I would only say only then think of it, otherwise don't go for it. Okay, this is how we go for pile foundation. We said that we have either end bearing piles or friction piles, etc. We classify them. But what I want to show is the behavior. You'll be surprised. Within 5 millimeter of settlement, I get all the shaft resistance. As you can see, the shaft curve, which is very steep, vertical, and flat. End bearing is a very slow one. And then I need probably 10% of the pile diameter for me to get the bearing and bearing resistance. So when I take a factor safety, let's say 300 tons is the ultimate load. I use 2.5, so I get something like 125, 140. If I put 140 tons, how much will go to the base? Hardly anything. All of it will go to shaft. We are all the time worried about end bearing. Honestly, at working load, very little load goes to the end bearing. You have to again look at it, how much is the load transfer between these two. Then when I have a large number of piles, isn't the zone of influence large? I look at the whole bulb action, loop action. So we look at different values of failure mode, etc. The biggest joke in our Indian code is a lateral loaded pile. It's the most atrocious, I can say. It says you can design a lateral loaded pile if you give one modulus of reaction. You have seen the soil profile so complex. Can I do that? And again, since 1960, we have all the solutions available for analyzing the lateral load capacity. Whether it's a fixed head pile, free head pile, I have charts for them. The code somehow, they don't want to change. And the other problem is actually I need to analyze compared to, a lot of structural issue also, Winkler foundation, I can use the same for pipes too. There's a lot of continuous, continuum approaches too. So I use all of these which are available in the last 50 years, 60 years. But our code is still 1964. And you'll be surprised. What is worse, I can tell you, is the scour. Do you know the story? This IRC has a code on scour. It was based on Lane's work in 1930. And what did he work on? Canals in Punjab, not a river. And we use that. I have a problem right now. Somebody said scour is 38 meters. So the pipe has to go 60 meters. And when you calculate the lateral load, 38 meters is a cantilever. Can I get any resistance on the scour? It's terrible. Okay. So this is the state of geotechnical practice. That's why I say, let's engage a qualified person. Don't believe on these quacks. I call them quacks. I mean, if I have a boring rig and about 5 lakhs, I can start the agency. And I'll say, I'll come to your site, I'll give you what actual cost maybe about 3,000 rupees per meter to do a proper job. How many of us would like to go to a roadside quack instead of going to a proper medical doctor if we have any health issue? The other thing is, you get done in a pathological or diagnostic test. There is a technician who takes your blood and gives to the report. Can you give the recommendation? Or you take that report to a proper doctor and get it? Why don't we do that? You think the guy who is sitting in the office there is qualified? Some guy who will get a job or whatever it is, MTech, so-called MTech, is doing it. And NABL, I can tell you, they get one test done and put a certificate and they will certify. Honestly, soil testing is not that easy. So that's the problem. I just wanted, I mentioned to our chief guest today, Bombay Municipal Corporation has made it mandatory. You need to have an independent geotechnical engineer for any project. When will we get there? Karnataka has that too. Do we have it here? I've been writing to GHMC. Please.
We have empanelment actually, but not being done properly.
Nothing. I mean, again, empanelment, who qualifies? That's a big problem. So this is the problem. You need to have, if you don't have, we pay the price. That's kind of. And I would like to say, honestly, it's a teamwork. If you don't work together, this is what happens. So please remember, we are all together. We are civil engineers. We have to work together, right? So when I teach geotechnical engineering, I may teach something in so, but when I practice, it's not simple rule based. You have to go beyond the rules. That's what I do. Thank you very much.
I have another analogy when I'm listening to Professor Madhav. He was comparing women and man initially. Now I want to compare structural engineering to mother and geotechnical engineering to father actually. I don't know how many of you experience this. Mother's love and affection you can experience right from the birth. And the structural engineer can experience structure right from the design basis report. That is mother actually. Whereas geotechnical engineering, I have been experiencing engineering days till now. I've been learning, understanding more and more as I'm working. That is father actually. We understand father till his last breath actually. And we can't understand completely even that. So geotechnical engineering is also like that. It is such a deep subject. We have to work on thousands of projects and infinite time. Then only you can really understand and get expertise. And Professor Madhav Garu is just 88 years young today. And he spent 1 hour with us. And he is like a father today for all of us in geotechnical engineering. Thank you.
If you have 5 minutes, I have whatever. Want to show what other countries do. Just to give you an idea, I have a project from one of my friends. It's shared by one of my friends. It's a building which they wanted to analyze. It had cracked. There was some, it's a very heritage building. It's a heritage building. It showed cracks. They said we had to find out what is happening. Okay, these are the details of the cracks. They all have that. So Then they had to do the analysis for the building, how it is deforming, etc. So they made again, please remember, it's a combined structure geotechnical interaction problem. So they put everybody together, analyze the model here, and then here is the soil investigation done in the site. Look at the kind of picture they got. These are the properties, the ground profile. Then they started settlement contours. Then they found out the horizontal displacement. Then they found out the crack pattern. Can you imagine ever we doing that kind of thing together in analyzing a building?